Welcome students. In this video we can talk about depth first search. We have seen how breadth first search works and why it's called breadth first search, and the main difference between breadth first and depth first search is the following: that breadth first search uses a FIFO queue, however depth first search uses a LIFO queue, and LIFO is we all understand LIFO is a stack, and stack means जनाब के last in first out. So but the thing that goes first will come out last. So let's see how it works. So again, this is your uh, frontier list. So again, we have stack A. So again, this is the only node that exists stacked. It will come out first. And let's say janab, with the pushing in this stack is going in this order. So first we have pushed D, then we have pushed C, and then which we have pushed B. So the reason I have written like this is because in pushing the first node that enters will exit last, and vice versa. But the first node that enters the last node that enters will exit first. So let's suppose B will exit first, and then you can see janab ke the frontier list will look like this. So B, D and C were there, and then the nodes of B will be pushed. So let's suppose G will be pushed first, then F, then E, and you can see the difference that the node that will first explode will be E, then F, and because E is turned black because E do not have any node, then F, and then G. F is turned black because there is no successor to F, and then G will be turned black because G will not have successor, and in turn B is turned black. That means they are put into the explode set because of the fact that they have been explode, and they do not there is nothing we can do with the following this path. Okay. And then we will follow C, and then H, and then I, and then J, and they will be turned black, sorry for the color, and then D, and then K, L, M. Once they are done, then D will be done, and then A will be done, and then if M would have been the goal, then the path that would have found was A, D, and M. Okay, but you can see the difference in approach from both breadth first search and depth first search. So depth first search, because it's implementing a queue, so it will see things in depth-wise manner. So that's why it's called depth first search, because it explores a depth first. Okay, so it explores that first, then this depth, then this depth, then this depth. Figuratively speaking, it explores a left hand side of solution first. It will always find the solution that exists at some left hand side or some left sub tree जो कि एग्जिस्ट का उसको पहला सोल्यूशन जो है उसको तलाश करता है. So again you can see the difference between breadth first search and depth first search is only in this line. So you can see the only difference between depth first search and breadth first search is this line, where whereas breadth first search was initialized as a queue, a depth first search has been initialized as the frontier has been initialized for depth first as a stack. Okay? And the rest is the same as what we have seen in the breadth first search. Okay, so this is again, it's not breadth first search. The depth first search criteria is so you can see the biggest disadvantage of using depth first search that it could stuck in infinite loop. So for example, if I'm moving from Karachi to Hyderabad, and maybe Gwadar, and maybe Fustar, and then from Hyderabad I can go to Moro, or I can go to let's say Thatta, and then I can also go back to Karachi. So if I start following this path, so let me choose another color. So if I start following this path, then I will be stuck in an infinite loop. So Karachi, Hyderabad, Hyderabad, Karachi, Hyderabad, Karachi, and so on and so forth. So I will be stuck in an infinite loop, and this would mean that my algorithm will never stop. The algorithm will not solve. That's why it's not complete. So if we have infinite depths, then it will not be complete. So we have to modify the loop. That's why we keep track of the explode states and the close states, as to keep track of all these repeated states, and that's why we can avoid these infinite loop. Okay, infinite spaces, it is complete. Time is b to the power m, because you can easily observe that we have to explore the whole tree to if the solution is at the rightmost corner of such tree, then we have to explore the whole tree to get to it, and the whole tree contains b to the power m nodes. Okay, so if m is larger or d is larger, then it's very bad. Okay, So if M is much larger than D, so if the branching, the breadth is small, but the depth is so the breadth is wide, but the depth is not, then this is bad for it, because if you exist at a rightmost point, it will reach you the last. ठीक है. But अगर आपको solution बहुत नीचे जाके मिलता है आपको, then it's very very faster than BFS, and you will see then in simulation that we will see that it outperforms breadth first search by quite a margin, as far as finding a solution in quick time is concerned. The good thing about it is its space complexity is linear, because it does not have to keep track of every node in a at a given level. It's just have to keep track of the nodes that come in a certain path, and that's the total number of nodes are b into m, which is very very good. So the space complexity is superb for DFS. That's why it's preferred in some criteria. It's not optimal, of course, because it will always find the solution that is at the leftmost path. So the first solution it will encounter, it will report, and it will not take into consideration the optimality factor. Okay, and we implement this thing using stack or LIFO stack, or French this is implemented using a LIFO stack. Okay, so how bad is DFS? So again, so time wise it's the same, but memory wise it is very 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 efficient. So for depth first search, so the breadth first search was taking 10 exabytes, but it will only take 10 kilobytes, 156 kilobytes to find the solution. So time wise bad, but memory wise superb. So that's why it is preferred sometimes if the solution is very deep, then it's preferred over breadth first search. So in the next video